Okay, one last scientific notation example, just to show that sometimes you'll have the scientific notation problems that will have some unit conversion stuff in them. And I don't think that makes it too crazy, but never hurts to put one of these in here in case you think you need to see an example to get you going. We are given a fact: the human body normally produces about 2 times 10 to the 6 red blood cells per second. So that's 2 million. And we would like to use scientific notation to express how many blood cells your body produces in one day. So I am starting with, I'm just going to write it down, this piece of information, and I'm just going to say cells so I don't have to write it out, per 1 second. So I'm starting with a fraction really, and I would like to convert this into cells per day. So the cells part is fine. I need to convert seconds into days. So if you know off the top of your head how many seconds are in a day, great. If you know how many seconds are in an hour, great. Otherwise, I hope we at least remember these basic ones. There are 60 seconds in 1 minute. That should cancel the seconds out for me. So that calculation would give me cells per minute. I also know that there are 60 minutes per 1 hour. So some people remember, after you have to mess around with these enough, that there's 3,600 seconds per hour. If you know that, you can use it. Otherwise, just break it into 2. It's not a big deal. I now have cells per hour. I'm close. I also know there are 24 hours in 1 day, and that will do it for me. Again, remembering that you always need to match units top and bottom. They won't cancel if they're on the same side of the fraction bar, but if they're opposite, you can cancel that. This means that my calculation is 2 times 10 to the 6 times 60 times 60 times 24, and that should leave me with cells per day. And I can plug in the 2 times 60 times 60 times 24. So again, I left the 10 to the 6 out for this step. You have other options, but this is one way to go about it. When I multiplied everything else together, I got 172,800 times 10 to the 6, and that's still cells per day. I like it, but that's definitely not in scientific notation anymore. I'm going to have to do a little bit more moving of the decimal place, so I need to move it an additional 1, 2, 3, 4, 5 spots to get that single digit out in front, which will give me 1.728 times 10, and I'd already absorbed 6 decimal places. If I absorb 5 more, that's 11 decimal places. So I've had to move 10 places in the base 10 system, which is 10 to the 11. And cells per day for my final answer. So that is an example of a calculation where you'll have to do some arithmetic and then you'll have to readjust your decimal point. We have one more part in this one. 1 pint of blood contains about 2.4 times 10 to the 12 red blood cells. How many seconds will it take your body to replace the red blood cells lost by donating 1 pint of blood? So we're trying to kind of convert 1 pint of blood into seconds is one way to look at that. Again, you can look at this other ways. If you see your calculation right away and don't need to do this as unit conversion, I'm fine with that. But that's one way to look at this, and it can be a really handy one. So 1 pint of blood, and I'm even going to go one step further, 2.4 times 10 to the 12 blood cells, because that's what we are working with up above. So I think that'll be more useful. And what I know, I don't want my final answer, I want seconds. What I know is that a body normally produces 2 times 10 to the 6 red blood cells per second. I can use that fraction here to make sure I get this operation correct. I need to flip it over though. I want to cancel out red blood cells, so make that over 1 if you'd like. In 1 second, We've created 2 times 10 to the 6 blood cells, red blood cells. So this is a division. And if you can look at that and you can see it's a division, great, you're done. If not, this dimensional analysis way of thinking is really cool. It sets things up so that you get the operation right. Okay, so that will give us seconds. This is actually looking like it's going to be a really nice calculation. I'm going to just group this together so that it's hopefully really easy to see. So I have 10 to the 12 on top, and I have 2 times 10 to the 6 on the bottom, and this is seconds. So notice I can cancel out some 10s. I have 12 factors of 10 on top and 6 on the bottom. If I knock out 6 of them, that leaves me with 6 on top as well. And then I don't even need a calculator for this one. I can do 2.4 divided by 2. I am seeing 1.2 times 10 to the 6 seconds. So again, playing around a little bit with these operations in scientific notation is really good practice for some of your science work. Thanks for watching.